Kinematics is the study of motion, and we're going to start to look and study objects that move in one dimension initially, and this means that they will move in a straight line. Examples might be cars and buses on a straight road, objects drop from a height from a cliff till they fall vertically, an athlete running a race. We're not going to consider what makes those objects move, but we will at a later time. We're just going to consider how they move. We'll also model most of the objects as particles, so that we'll ignore their size and their shape and just concentrate on their movement. But first we've got to define some words and some symbols and some units. In everyday language we use the terms speed and distance when talking about motion. We think of distance as how far we've travelled, maybe in miles or in metres or kilometres. And speed we understand to be how fast we've gone, miles per hour perhaps, or metres per second. In the study of kinematics we need to be a little bit more precise about these concepts, and we introduce the terms displacement and velocity. These terms are very similar to distance and speed, but displacement and velocity have more of a precise meaning, and in fact they're based on the distance and the speed from a specific origin or reference point, but also taking into account the direction of motion as well. Displacement may be, for example, 5 kilometres north from a reference point or origin, or it may be given using positive or negative values relative to an origin. Let's suppose we have a straight road, as in this diagram here, and let's suppose we say that the origin is here, point O, and the positive displacement is in this direction, and negative displacement is in this direction. Supposing I have a point P here, which is, say, 3 kilometres. We say the displacement of point P is 3 kilometres. And supposing I have another point here, Q, which is 2 kilometres, but it's in the other direction, it's to the left of the origin. We say the displacement of Q is minus 2 centimetres. And in kinematics, the symbol that's usually used to describe displacement is the symbol S. So supposing I start at the origin and start walking towards point P. I get to point P and I turn around and I walk back past the origin to point Q. My displacement S is equal to minus 2 kilometres, because I've ended up 2 kilometres to the left of the origin. However, the distance I've travelled is different from the displacement. In fact, the distance I travel is the 3 kilometres to the right plus the 3 kilometres to the left, and then a further 2 kilometres to the left. So I've walked 3 plus 3 plus 2 kilometres, which is 8 kilometres. So this shows the difference, the subtle difference between distance and displacement. In 2 dimensions, the difference between distance and displacement might become a little bit more obvious. Supposing we start here at a point 0 And let's suppose we're on one side of a river and we want to get to point P, which is on the other side of the river. And suppose the only way we can do it is over a bridge, which is up here. So we walk along here, up to this point, over the bridge, and then to point P. And let's suppose that this is 2 kilometers, this is 1.5 kilometers, and let's suppose the bridge is half a kilometer. That's quite a big bridge. The total distance we've walked is 2 plus 1.5 plus a half, which equals 4 kilometers. But the displacement of point P from point Q is different. In fact, let's say that it's half a kilometre. The displacement S is half a kilometre. So we can see that distance and displacement are quite different quantities. In fact, if an object starts at a location O, for example, and just moves about, so it's travelling quite a large distance, but if it ends up back at its starting position, although it's travelled quite a large distance, its displacement S is 0. It isn't displaced from the starting point, but it's travelled quite a large distance.